All right, remote calculus. Welcome to homework set number 2 for Limits Revisited Spring 2021 help videos. Homework set is due Friday the 26th by 9 a.m. So you have the instructions, evaluate each limit if it exists. Now I will tell you that you can cross out 13. You can get rid of 13. All right. Bye-bye. It's a 13. Just put free points or something. Okay, so that said, I've given you some that should look very familiar. So these serve as your notes. Here, evaluate each limit if it exists. First one here, the limit is x goes to 0 of 3 over x squared plus 3x minus 1 over x. What we need to do is what we've done last year. We would have factored this bottom here. That's x times x plus 3. So this has an x. They both have x's. This has an x plus 3. This needs x plus 3 over x plus 3. I'm going to subtract x. I'm going to subtract 3. I'm going to combine them. My common denominator is x over x plus 3. Get Honors Algebra 2, Chapter 8. Nothing different there. 3's cancel. I'm left with a negative x over x times x plus 3. You know what happens. The x's cancel, leaving you with a negative 1 over x plus 3. The limit as x goes to 0. I can let x be 0 now. Negative 1/3. Okay, so 2 kind of looks like the difference quotient there. Just going to square x plus h. Notice that the x squareds cancel. If you have to take x plus h and cube it, well then, take x plus h and square it, then multiply it by x plus h. You can do that. Here's what I'm left with. Both of these have an h. I can factor out the h and divide by h, or I can just divide everything by h right away. And then I can let h be 0. 2x. On 3, I'm going to FOIL this out. 9 minus 6h plus h squared minus 9 all over h. Again, the limit as h goes to 0. The 9's cancel. The h's cancel. Plug 0 in for h. All right, so on 4, I'm going to multiply top and bottom by 2 plus root x. If you wanted to, while also I'm going to factor out the x that these two have in common, leaving me with 4 minus x. All right. Up top, I'm going to have 2 times 2, 4 minus x. 4 minus x is literally cancel. Again, you're left with 1 over x times 2 plus root x plus, or plug 4 in for x. Square root of 4 is 2, 1 over 16. All right, now we have limits involving infinity, and as we'll see here shortly, these are just using our horizontal asymptote rules. Limits involving infinity. So you have this one. The limit as x goes to infinity. Again, infinity over infinity, negative infinity over infinity. Those are also indeterminate. Same thing as 0 over 0. They don't tell us anything. Okay, so you don't ever want to use 0 over 0 as an answer, or infinity over infinity as an answer, or negative infinity over infinity, or infinity over negative infinity. You get it. Don't use any of those. So I'm going to divide everything by x squared. Literally every single term is being divided by x squared, okay? Then what's that leave me with? Okay, well now if I let x be infinity, if I have negative 5 divided by infinity, that's essentially 0. 2 divided by infinity, doesn't matter if it's being squared. All right, that's essentially 0. 7 over infinity, still 0. So I'm left with 3/4. The limit as x goes to infinity of 3 over 4. Well, there's no x there, so it's going to be 3/4. Notice how you had the same highest power. You had the same highest power, and my answer was the ratio of the leading coefficients. That would be important. We'll talk about that in a second after we look at all 3 types. All right. So on this next one, I'm going to divide everything by x to the 3rd. Let's divide everything by x to the 3rd. That highest power I see in the denominator. Divide every single term by x to the 3rd, just like I have there. Here's what I'm left with. Okay, again, 3 over x, 7 over x to the third, negative 5 over x, 8 over x squared. If I'm letting x go to infinity, those are all 0. Now, if I let x go to infinity, infinity squared is still infinity. I'm going to be left with this, infinity over 1, which is infinity. All right, some places might say limit does not exist. We're just going to put positive infinity. I mean, technically it doesn't exist going to infinity. All right, so notice, so there's no horizontal asymptote too. So notice how the highest power was in the numerator. Highest power in the numerator means there's no horizontal asymptote. Okay, it's not bounded by above, so the limit's going to go to infinity or negative infinity, depending on where you're looking. Again, some places might say limit does not exist. 7. Take a look here. I'm going to divide everything by x to the third. Highest power there in the denominator. Divide every single term by x to the third, like I did there. All right. I'm going to let x go to infinity. You're going to have 5 over infinity minus 4 over infinity over 3 plus 7 over infinity. Anything that's being divided by infinity is going to be 0. Left with 0 over 3, which is 0. Folks, if the highest power is in the denominator, then the horizontal asymptote was y equals 0. Okay, so if, and you're just eventually going to be able to take a shortcut. If the highest power, if you have the same highest power, then the limit as x goes to infinity or negative infinity is going to be the ratio of the leading coefficients, 3 over 4. If the highest power is in the numerator, then the limit's going to be, you know, basically undefined. It's not going to be bounded by, there's going to be no horizontal asymptote, depending on which way you're going, infinity or negative infinity, limit does not exist, type of deal, not bounded. All right, if the highest power is in the denominator, then the horizontal asymptote is y 0, and then the limit is 0 if the highest power is in the denominator. All right, so let's take a look at this one. So folks, we really care about the highest power. So this one is essentially the square root of 4x to the fourth. That's the highest power. That one carries the most weight over, again, some place might have you, divide everything by x to the fourth. We're going to arrive at the same answer. Over the square root of x to the fourth. Again, this is now more important than that. If I divided by everything by x to the fourth, you would see it as we found above. The square root, notice I'm using, the kind of the approximately symbol there. The square root of 4x to the fourth is, in fact, 2x squared. The square root of x to the fourth is, in fact, x squared. Now you have the same highest power. So the limit as x goes to infinity of 2 is just 2. The ratio of the leading coefficients, 2 over 1, is also 2. I'll let you answer 8 and 9 like I'm showing here. So the limit as x goes to infinity of the square root of this over that is basically the limit as x goes to infinity of the square root of 3x squared over 5x. If x is going to infinity, that definitely doesn't matter. All right, well, the square roots of 3x squared would be x root 3. The x's cancel. You have the same highest power now. So the ratio of the leading coefficients would be root 3 over 5. That's my answer. Last page. So 10, I just foiled the top, then I foiled, then used distribution. That's probably, again, you're going to be able to see that you're going to have 16x to the fourth over 2x to the fourth. You're going to have the same highest power, so 16 over 2 is going to lead me to 8s, but just do all that algebra first. Now you have the same highest power. Write that down, same highest power, x to the fourth, x to the fourth. So the limit is just the ratio of the leading coefficients, 16 over 2, which is 8. Do the algebra, show me that you know it's the same highest power, and then we got it. Okay, let's take a look at 11. Whoa. So infinity minus infinity is also not a suitable answer. So this is the limit as x goes to infinity of x minus the square root of x squared plus 3x. That's a plus 3x. So I'm going to multiply the top, and I'm going to make a bottom by the conjugate, x plus the square root. And when I do that, I'm going to have x minus minus x squared, but then I'm also subtracting 3x, okay, all over the conjugate. The x squareds cancel. And now this is basically the same thing as negative 3x, because it is, over x plus x squared. X squared is the most important term inside the square root. Who cares about that 3x anymore? The square root of x squared is x. Now I've got the same highest power. So instead of being 0, it's negative 3 over 2. A much different answer than 0. All right, so now, you know, the highest power is in the numerator. We can say the limit does not exist. I'm going to divide everything by x squared. You know, I think we should give this. As x is going to negative infinity, you know, you got x squared, negative infinity squared. So you can write limit does not exist, infinity. That's fine on that one. Highest power up top, limit does not exist. No horizontal asymptote. All right, this is your review video for homework segment 2. This is Yak Math Videos signing out.